Hi everyone, welcome back to our videos where we were discussing about time complexity and we have concluded several examples on how to calculate time complexity based on basic operation count. While going through all the process, we have seen that we were getting different time complexity like n square, n power 4, log n log n, all those. In this video, we are going to discuss about those stuff which we were getting as an output of time complexity. So you got that the time complexity were like in the form of n square, n cube, log n and so forth, right? Actually, we have certain classes which we call as efficiency class, right? This class is nothing but certain forms. I consider them as certain forms, right? So all those forms are called as efficiency class of algorithm. For example, if you getting a constant, right? So this is one of the class of efficiency. So any algorithm can be from these class, which cannot be a fixed. This list cannot be a fixed. It can vary, right? But any algorithm will have its own class, right? It belongs to its own class. For example, n square is one of the class. So you can have a algorithm with n square time complexity. You can have algorithm with n cube time complexity, log n complexity, n log n complexity, n cube, 2 power n, 3 power n, n factorial, all those stuff, right? So sometimes the question may come to ask the comparison between the two algorithms, which one is faster, which one is slower, which one you should go with. In that case, what we do is we find time complexity and then we compare their time complexity, right? Which is better, which is not. So I'll just give a small though you can find out which one is good. For example, if I find n square is more or n cube is more, so you can put the value. For example, you put 2, so 2 square is 4 and 2 cube is 8. So obviously this is more greater, right? So sorry, this is more greater. So n square, this relationship will hold. So you will choose this algorithm because this holds the less time complexity with as compared to n cube, right? So that is why. So these forms are nothing but called as efficiency class, and we should know an order of these efficiency class. So I'm writing one typical order, but I have already told you a thumb rule is that you put the values, put some values, hash hit and trial method, and use hit and trial method by putting some values to compare the efficiency classes, right? Efficiency class. For example, you are doubting whether 2n or 3 factorial, which one is good, right? Or n factorial, yeah, 2 power n or n factorial, which one is good? So what I'll give, I give a 3 as a value. So 2 power 3 is 8 and 3 factorial is 2 into 3, that is 6. But so this is one value, right? So in this case you said this is the best, but you should give more values. For example, if I give 5, right? So 2 power 5 is approximately how much? 8 to the 32. And if you say 5 factorial, it will be 2 into 3 into 4 into 5. So 6 4s are 2 3 is 6, 6 4 is 24, 24 5 is 72, 125, right? How much it is? 6 and this. So you will find this is 3-digit number. So obviously this is great. So that's what I'm saying. You should put some values, okay? Not just one, and do the hit and trial method, right? But you can write this, or you can remember this typical order. So you will have constant. So constant will hold the least values. Then compared to log n, then n log n, then n square, then n cube, then 2 power n, and then n factorial. So again, I told you this is not a fixed list of efficiency class, but it is the most widely used. And if you go through a new efficiency class, you can find out by just putting some of the values. At least put different ranges, that is 1 to 10, 10 to 100, and 100 to 1000. So by this you will get the values. right? In some cases, put the favorable values, right? If you put in 2 power and in this range, you are gone. But you can take an approximation somehow and do that, right? This is how we figure it out, efficiency of classes, efficiency of algorithm, sorry. So if you like the video, please do like, share and subscribe. Thank you.